Hi guys, so today we're going to be learning about inscribed angles and angle measures and different properties that come from that. So we're going to start off with our toolbox section and some vocab words. Okay. So this time we have a different type of angle. It is known as an inscribed angle. Okay. It is an angle where the vertex is on the circle and then the sides of the angle are your chords of a circle. Right? So an example here is this is an inscribed angle. Okay. The vertex is at the center and the sides are chords, and we know that because they touch the circle in two places. Right. Another example is here, angle ADB is an inscribed angle. Right. Vertex is here on the circle at D, and then the sides are formed by the chord AD and the chord BD. So with an inscribed angle, what it has is it creates an arc. Okay, the arc that is in the interior of the inscribed angle, okay, and where the end point on the angle is called the intercepted arc. Right? So here, if this pink is my inscribed angle, this is the intercepted arc. Right? Here, if I have angle ADB, this AB here is my intercepted arc. Okay. And what we know is that the measure of an inscribed angle is going to be half the measure of the intercepted arc. Okay. So that we see here. The inscribed angle, angle ADB, whatever degrees it is half the number of degrees of this arc, of arc AB. Okay? So you do need to know the vocab. I would do flashcards to help me remember it, and then flashcards of the different properties as well. Okay? So here's the next one. Okay, if we have two inscribed angles of a circle, if they two inscribed circles, okay, if they have the same intercepted arc, then their angles are congruent. Okay. So here is an example. We have two inscribed angles. Right? One inscribed angle is ADB. Right? Vertex on the circle, the sides are chords. Right? Here we have another inscribed angle, ACB. Okay, note that they have the same intercepted arc, right? They intercept the same arc here, right? Then their angles are going to be congruent. And then here, one of our last properties for this section is that an angle inscribed in a semicircle. Right, so here we have an angle inscribed in a semicircle. So this is this here. Okay. This angle, angle ABC, it's inscribed in a semicircle. Right. The two end points here is a semicircle. It is a right angle. So that's one part of our highlighting, and then I'm going to section this off so we know that I'm going to repeat the colors, but they now mean something else. Okay. So here, since we're talking about inscribed angles, right, we also have inscribed polygons. Okay. So here, an inscribed polygon is a polygon where all of its vertices are on the circle. Right. So here we have an inscribed triangle. Note that the vertices of the triangle are all on the circle. Okay. Here we have an inscribed quadrilateral. Okay. All of its vertices are on the circle here. Okay. And then the circle around it is known as a circumscribed circle. Okay. So this is the circumscribed circle. This is the circumscribed circle. Okay. We're going to eventually learn how to construct these. Okay. The thing that goes with this, okay, is that when we have a quadrilateral inscribed a circle, right? So here is an example, right? We have a quadrilateral inscribed in a circle. Note its vertices are on the circle. Okay. Then what we know is that the opposite angles are supplementary. Okay. So example of that, angle E here and angle G, they are not congruent, they are supplementary. So the measure of angle E plus the measure of angle G here, I should have labeled it with multiple letters, my bad, but it's okay. They equal 180 degrees. Right. They are opposite each other. Yeah. So when you have a quadrilateral, four-sided shape inside a circle, okay, where the vertices all touch that circle, opposite angles are supplementary. Right. So example, angle E, angle G are supplementary. They're not congruent. Again, supplementary does not mean congruent. Supplementary means adds up to 180. Right. So then angle D here, 1, 2, 3, 1, 2, 3, 4. So angle D and angle F are supplementary. So let's do blue. That's what this is saying. There you go. Okay. So that's for inscribed polygons. This is specifically for quadrilaterals, this rule. Okay. And then last section of our toolbox before we do some example problems. Okay, so here, if an angle is formed by a tangent and a chord, okay, it is half the measure of the intercepted arc. Right? So an example here, this is the tangent line. Tangent and a chord. Okay. Note that it forms two angles. Okay. The measure of the angle is going to be half of the intercepted arc. Okay. So let's do it this way. Okay. So here, angle 1. Here's angle 1. Angle 1 is half of its intercepted arc. It is half of arc AB. So next one, angle 2, right, formed by the tangent and a chord. It is half of its intercepted arc, which is formed as BCA. There you go. Okay, so let's get practicing and let's see some of them in action. Okay, so here we want to find the indicated measure angle P or circle P here. Okay. So the first one we're going to do here is measure of angle T. So angle T is here. Okay. So keep in mind, right, the angle is half of the intercepted arc, so it is going to be half of the 48, right? Because the intercepted arc for this is 48, so it's going to be half of 48, which is 24. So angle T is 24 degrees. Okay. Then here, the next one is I want the arc, right, measure of the arc of QR. Note that little symbol here means arc. So here I want arc QR. Okay. So this one's a little bit harder. Okay, so first of all, I would need to find this out. Okay, So if this is 50, this is an inscribed angle. That means this is 100 degrees. This section here. Okay. And then this is a semicircle, right? It's formed by the diameter. Right, so this here is a semicircle. That would be 180, right? Half of the circle, 180. So to find QR, it would be the whole thing here, 180 minus 100. Which gives me 80. So next one here, it asks me to find the measure of arc RS and angle STR. So here, arc RS is this. Okay. So let's start with arc RS. So arc RS is formed by the inscribed angle SUR, okay, or RUS. Okay. So SUR and RUS, since this inscribed angle is 31 degrees, the angle is half of the intercepted arc, right? So measure of arc RS, okay, half of it would be the angle measure. So let's do another color. Okay. So here, arc RUS, this, right? This inscribed angle makes this intercepted arc. Okay. And we know that the angle is half of the arc, so we can fill in what we know. Okay. So if this is half of whatever the arc is, angle RUS we know is 31 degrees. Okay. To find this, if this is half, the opposite of half is to multiply by 2. So to get arc RS by itself, I'm going to multiply by 2. I'm going to multiply by 2. This undoes each other, leaving me with the measure of arc RS equals 31 times 2 is 62. So arc RS is 62 degrees. Okay. Then, if this is 62, okay, the next part of the question asks me for STR. Okay. So STR here is this, angle STR. Okay. Note that angle STR is the inscribed angle. SR is its intercepted arc. So same thing. Half of the intercepted arc is the measure of the inscribed angle. Okay. Measure of arc RS we just found was 62. We just found it was 62. Half of 62 is 31. So the measure of angle STR is 31 degrees. And so here we go. Okay. And so then it asks us, what do we notice about STR and RUS? Okay. So what we notice is that the measure of angle STR is the same as the measure of angle RUS, right? Both of them are 31 degrees for that angle. Okay. So we notice they are congruent. And the reason why is because they both intercept the same arc. Okay? And that is why whenever they intercept the same arc, they're going to be congruent. Okay. So here's our next part. Right? So we want to find the measure of the highlighted arc or angle. Okay, so do that here. If your highlighting isn't clear, just highlight it here now. Okay, so it's here, it's this, and then it's this. Okay. So again, remember the inscribed angle is half of the arc. Right? So if you want to write that somewhere, you can. Inscribed angle is half of the arc. So here, the inscribed angle, in this case, that's here, HGF, is going to be half of the measure of arc HF. Right. Inscribed angle, half of the arc. Okay. HF we know is 90, so half of 90. Half of 90 is 45. Okay. So the measure of angle HGF is 45 degrees. Okay. So next one here. Okay. So inscribed angle, this is its intercepted arc. So again, the angle, so in this case TUV, again is half of the arc. Angle TUV we know is 38 degrees. Get rid of the half. Opposite of half is 2 times 2. So 38 times 2 is 76. So here the arc is 76 degrees. Okay. So here's our next one. Oh, I think this is supposed to be a W. Okay, got cut off. Okay, so here we see an inscribed angle, 72. Right, so the measure of that angle, ZYW, is half of that arc. That arc is ZW. Okay. Here the angle is 72. It is half of that arc. So here, multiply it by 2. This gives us 144. Okay, so that means this arc here is 144 degrees. Okay. Then it has the same intercepted arc as this, so here this is 72 as well. Okay. So for this one, remember, if it intercepts the same arc, they are congruent. So since they intercept the same arc, they're congruent. So here, instead of even doing all of this work and then going backwards to get back to the 72, we know if it intercepts the same arc, they are congruent, because this is equal to this. Okay. Okay. Next one here. Okay, we want to find the value of each variable. Okay. So note here for all 4 of these, right, I have an inscribed quadrilateral, 4-sided shape, inscribed into a circle. Note the vertices are all on the circle. Okay. What that means is opposite angles then are supplementary. They add up to 180. Right? So for example, here, the 80 and the x add up to 180. Okay, so 80 plus x equals 180. Subtract 80 on both sides, x equals 100. So same thing for this. So 75 plus y here. Subtract 75 on both sides. Y equals 105. Nice and easy. Okay. Looking at the next one here. Okay. So maybe. Okay. So here, opposite. This and this are opposite. So here, 2a plus 2a equals 180. 2a plus 2a is 4a. Divide by 4, a equals 45. Okay. So when we have a quadrilateral inscribed in a circle, opposite angles are supplementary, meaning they add up to 180. So 4b plus 2b here equals 180. 4b plus 2b is 6b. It's 180. Divide by 6 on both sides, b equals 30. Same thing with the next one here. Again, opposite angles for our inscribed quadrilateral are supplementary. So x plus 82 equals 180. Subtract 82 on both sides, x equals 98. Opposite angles are supplementary here, so y and 68. Subtract 68 on both sides, y equals 112. Okay, last one before we do the other one here. Okay. So again, opposite angles are supplementary, so C, it's pointing to this here, so C plus 2C minus 6 equals 180. C plus 2C is 3C's. Add 6 on both sides. 3C equals 186. Divide by 3 on both sides. C equals 62. Okay. And then last one for this one here. 8x and 10x. 8x plus 10x is 18x. Okay. Get rid of the times 18 by dividing by 18. X equals 10. Okay. And there you go. Okay. Last one here is where we have line N, for all of them, is tangent to the circle. We want to find the measure of the indicated arc. Okay. So keep in mind here, the measure of the angle is half of the intercepted arc. So measure of angle is half of the measure of the arc. If you can't see which one's highlighted, it is this here. It is this. It is this here. It is this, and it is this. Okay. So again, measure of the angle is half of the arc. So here, measure of angle 1, which is what I'm looking for, is half of that arc. Half of 130 is 65. Okay, so measure of angle 1 is 65 degrees. Okay. And the next one here. So measure of angle is half of the arc. The 125 here is for that angle. So that's 125. It is half of the arc. So this arc is KJL. Get rid of the half by timesing 2. 125 times 2 is 250. And so arc KJL is 250 degrees. Okay. Next one here. Again, measure of the angle is half of the arc. So measure of angle 1 is half of the arc, which is 210. Okay. Half of 210 is 105. So angle 1 is 105 degrees. Okay. Next one here. This 98 refers to the angle. So again, angle is half of the arc. Okay. So get rid of the half by timesing 2. And this gives you 196. Okay, and the last one. Okay, this 80 degrees stands for the angle here. Okay. So again, measure of the angle, 80, is half of the arc. Okay, get rid of the half by timesing 2. So 160 degrees, oops, I forgot degree symbol here, equals the arc of XY. And there you go. That's it for today. Have a great rest of the day. Bye, guys.